launch of the Thanks. It's a launch of the ACT in Math webinar series. And as you heard, ACT is an acronym meaning Advancing Caribbean Teachers in Mathematics Education in the Caribbean, right? And today we just want to give you a sense that it's a project that started last year, and it began with 3 countries in St. Lucia, St. Vincent and the Grenadines, and St. Kitts and Nevis. So it started with us wanting to support the teachers in those 3 countries with improving their pedagogy, improving their confidence, their competence in mathematics education, and how they can reach the learners to also improve mathematics performance. In those 3 countries, we started with students who are at the primary level, so working with those teachers, in-service teachers, coaches, curriculum officers, student teachers who would want to build their competence and confidence in the area of mathematics. And the project rolled out with a 2-day workshop in each of those countries, where the call expert, Dr. George, facilitated the sessions with those teachers. In total, we had over 80 teachers benefiting from the workshop support, followed by a community of practice where the teachers met periodically to engage in conversations around critical areas of mathematics to support and to discuss what they experience in their classrooms, and to share best practices among themselves and to get feedback. The teachers also had a virtual online platform space where they could engage with open educational resources to build again on their deficits, gaps, wherever the need might be, and also to reaffirm areas that they were strong in, but probably need more variety in terms of maybe assessment, possibly about how to integrate OER and AI in their teaching and learning. So it's that kind of tripartite approach to professional development that this program targeted. And so we had the teachers, the majority of them staying with the program to the end. And so we have a model that we are now rolling out and making available for other Caribbean countries, because as we said, we're looking to advance Caribbean teachers' competence and confidence in math. So in this second cycle of ACT in Math, we are working with teachers in Barbados, in Grenada, and Dominica. And so we're really thankful for that. The Commonwealth of Learning is extremely happy to be able to support the needs and the work in mathematics education in the Caribbean. We know that STEM is especially important. Math is an area that opens doors to further education for career pathways. And without that kind of gain in math, our students do not stand a winning chance. And so through the support of the Commonwealth of Learning, we are happy to do this. So on behalf of the President and CEO of the Commonwealth of Learning, Professor Peter Scott, along with the Director for Education at CALL, Dr. Tony Mays, myself, the advisor for the Virtual University for Small States of the Commonwealth, Dr. Chantal Moore, and also the Program Assistant, Ms. Carol Walker, and other colleagues at CALL. We are supporting this webinar, and we're really happy for how it will turn out. I know today Janella, will do an amazing job, and we look forward to hearing from Janella. And we just want to support and encourage all the other facilitators who will be presenting in this webinar series. Dr. George, kudos to you as well for, taking this further and, making it redound to impact of the project that we started. And we know that you will go on to do amazing work across the Caribbean, and CALL stands behind you, beside you, around you to support you, because we also believe that through this project, every child will get the opportunity to learn, to develop their confidence in math. And also we know that every teacher deserves to be gifted with the tools and the support that they need to, just be better at their craft. So thank you on behalf of the Commonwealth of Learning. Thank you.
Thank you so much, Dr. Moore, for your insightful remarks and, very importantly, your leadership in this important initiative. We are well aware with some of the statistics that we have been seeing in regional examinations over the past few years. And we know that we have some work to do. And the UWI, with partners such as the Commonwealth of Learning, as well as, our ministries of education, we are coming together to be solution oriented. It is one thing to know what the problem is, but we want to say, okay, how can we support our educational stakeholders, teachers, leaders, teacher educators, and I know we have some parents in the room who, you are saying, I want to assist further in helping my child or my children, and therefore I'm here to learn more. So today's session, the first in our series, is titled From Blocks to Brilliance, Building Number Sense with Base-10 Tools. And this focus on strengthening foundational number sense, it's really critical to improving math performance, because number sense underpins so many topics in number and beyond. And we are focusing on the use of a variety of tools because we believe fundamentally that the use of different representations in the teaching and learning of math is important for our students to develop flexibility and fluidity in terms of the content that they are learning. So we will be utilizing, so in case you are on a device, whether it's your phone, your tablet, your laptop, it is not just you sitting back and watching, but we also want you to participate in this very interactive, we hope, session. So without further ado, we don't want to spend too much time. I know it is late for you in the Eastern Caribbean. It is 5 o'clock in Jamaica. It is 4, and in Belize, it is even later. So it is my pleasure now to introduce our presenter, Ms. Janella Gifford, who is a curriculum officer, the curriculum officer for mathematics in St. Lucia. And with 25 years of experience in education, Ms. Gifford comes to us with this wide range of competencies, and she has taught at different levels, such as from primary, grade 2 and grade 3 through the bachelor's degree level. And she has a particular philosophy on teaching and learning mathematics. It is that every student comes to school with a love for mathematics because every child can learn it. What we are seeing currently is that many children, they do not have a love for it. And we question whether every child can learn math, but we are holding on to this particular view that every child can learn it and they can love it. So Ms. Gifford Janella, she hails from the island of St. Lucia, and she has served as mathematics curriculum officer within the Ministry of Education for the past 13 years, where she leads curriculum development, monitoring, implementation, and teacher professional development initiatives. She has contributed as a country lead and reviewer of the Organization of Eastern Caribbean States Harmonized Mathematics Curriculum. Our OHPC facilitated countless of teacher training sessions. And like most of us in the room, and certainly me, she's a champion for hands-on student-centered strategies, particularly the concrete pictorial abstract approach, the CPA approach. Ms. Gifford is also a CSEC SBA moderator and marker for mathematics, and recently collaborated with CXC to validate numeracy standards and performance criteria for lower secondary mathematics. Earlier this year, she coordinated St. Lucia's participation in the Acting Math project. We didn't consider ourselves guinea pigs because, the first persons out of the gate are usually considered that, but no, as part of that endeavor, the first group really set the stage and the foundation for what is an amazing project that's sweeping across the Caribbean. So if it has not yet come to your island, just keep listening out. Acting Math is coming to you. Finally, Ms. Gifford is a strong advocate for rigorous standards in assessment and curriculum, always committed to meeting the diverse needs of all learners. And we are truly privileged to have her to lead today's session, our first session. So again, through your emoticons, emojis, etc., let's make her welcome. Let's give her our attention. And Ms. Gifford, over to you. Do what you do. All right. Thank you so much.
Thanks. Good afternoon, everybody. Can you hear me?
Loud and clear.
All right. Yes, thanks for such a warm welcome, Dr. George. I do feel welcome. I'm seeing that we have quite a bit of persons on the platform this afternoon, which is testament to the fact that persons want to learn something or just to get a boost as to what it is that they already know. All right, so participants, welcome. Dr. Moore, I think we have some persons we have persons from all over the island, sorry, the Caribbean. Oh my gosh. Just a little bit of nerves there kicking in, but I'll be all right. All right. I'm just trying to share screen. All right. Can you see my screen?
Yes, we can.
Okay. Just give me a sec. One second. Okay. Ooh. My screen is a bit frozen there. Hold on. What's happening there? Okay. Right. Okay. There we go. All right. So as we start this afternoon session, from blocks to brilliance, building number sense with Base-10 tools, I would like to engage your eyes, your ears, all your senses, because all that is part of number sense. The irony, right? The first aspect of the first part of the ACT program that we did, Achieving Caribbean Teachers of Mathematics, Dr. George coined the phrase, think like a child to teach a child. And I'm adding the piece mathematics. And this phrase has had such a profound impact on the way that I see mathematics. She had us to rethink. She had our teachers to rethink when it comes to the teaching of mathematics to students, that we have to go out of ourselves and bring in the inner child and think of the child that we are teaching mathematics so that we can reach every single learner. So equity, equality, and of course, reaching the child at the lowest level will be the effect. So for those of you who are new to this, those of you who are online, who are just joining for the first time, it is something that I would like you to take back with you and to be a bit open-minded as we delve into the theme for this afternoon, from blocks to brilliance, building number sense with Base-10 tools. Think like a child to teach a child. The objectives or outcomes for this afternoon sessions, we are going to do try to understand the foundation behind number sense, explore Base-10 blocks using the concrete pictorial abstract approach, identify a few tools and ideas using Base-10 blocks, and of course, some real-world applications of Base-10 blocks. So we have a little activity there to break the ice. So you can see from your screen, and just post in the chat for me, please, the answer to this question. And I shall read in your hearing. A sum of money in the amount of $1,112 was deposited at the bank. There were 42 $1 coins, 9 $100 bills, and there were some $10 bills. So can you find how many $10 bills were there? I shall read. A sum of money in the amount of $1,112 was deposited at the bank. There were $41 coins, 9 $100 bills, and some $10 bills. How many $10 bills were there? So you have about 2 minutes to just post your response in the chat. All right, we have some persons posting in there. Okay, I'm seeing 17, somebody posted 170. Somebody puts, assuming that all the rest were $10 bills. Yes, all the rest were $10 bills. There's a bit of calculation as well. All right. Okay. We have some with most persons. So I believe we can agree that it's 17. Now you're probably wondering why, or the purpose for that as to set the tone for the session. Generally, and based on the thrust of what we're heading towards this afternoon, looking at number sense, Base-10, looking at the Base-10 theory, normally, what do? We ask the question, how many tens, how many hundreds, how many ones, how many thousands? That's a question we normally ask students, and within the context of whole numbers. But the purpose here is to give you a context, a real life context of what we would experience when we deposit money. If we go to the store to buy things and we have a lot of loose cash and then we're grouping things together, this is what the outcome is. So this is more or less, it is a connection. It is a realistic connection of the application of what we are going to explore this afternoon in terms of place value, in terms of Base-10. So we don't want to just isolate and have it abstractly brought to the students, but we want them to connect what it is that they're learning. So in terms of reading and writing numbers, division, grouping the numbers, looking at place value, this is a direct interweaving with the concept of place value. Okay, yes, so our 17 people, yes. 17 pats on the shoulder. All right. Okay. Screen is frozen again. All right. So that takes us to our next slide. What is number sense? So basically, for us, the building blocks of learning about numbers and ensuring that students understand the concept number, it stems from number sense. So what really is number sense? It's your ability to think fluidly, flexibly about numbers. It is not just knowing the facts. So I can blurt out facts. 2 times 1 is 2, 2 times 3, but where is the application? So it's knowing the relationship that exists between and among numbers, and you will have seen that in the icebreaker that I gave here, there is actually a connection between learning whole numbers as well as learning about money. Without a strong number sense, place value and regrouping become memorized steps. Number sense, it actually prevents rote memorization errors, not negating the fact that there is not a place for rote memorization, because there are some facts that students need to understand, but having a strong number sense, it prevents the errors that students would normally make. And number sense points to the fact that why math works, not just the how, not just the procedural, but the relational understanding that speaks to the why students are learning what it is that you're learning, the critical thinking, the reasoning, the problem solving. So why? And this is what number sense is. It is the key to strengthening math skills at a very early stage. So I put before you a graphic organizer in terms of what number sense. So as you process, what does number sense speak to? We have skills, mathematical skills. We have calculating, we have classifying, we have reasoning. We have a number of mathematical skills that come into play in order to achieve that sense of number. Language, we know language is something that we just cannot run away from when it comes to mathematics. It's not just about numbers, it's not just about calculating, but language plays an important role with achieving that sense of number. The language arts skills, listening, speaking, reading, writing, visually representing. This is part and parcel of developing number sense as we teach our students. The tools, in terms of the tools, the manipulatives. So we go straight back into the concrete. Students at an early stage need to be presented with that hands-on approach to learning. We don't want to make it too abstract for them at an early stage that they get frustrated. So the necessary tools to build those concepts have to be presented to them at an early stage. Well, not just at an early stage, right throughout, going from concrete to pictorial to abstract, and that will be depending on the context. But we are for the CPA, concrete, pictorial, abstract. Mathematic models, the models that we may use, giving them scenarios, problem-solving scenarios, okay? The big idea, what is the big idea of number sense? That was on the previous slide. Fluidity with numbers, flexibility, knowing when to use it, using mental strategies, okay? And of course, the strategies in terms of problem solving, in terms of use of visuals, mental maps. So everything is interwoven here as we develop number sense for our students. Again, the visual is presented to you. This, we're starting from the basics. This is not exhaustive, but these are some of the things that we can present to the students as we teach. The interlocking cubes, helping them to build their fine motor skills as they lock the cubes, and they are creative and they create things, they create patterns, they're counting. Okay, they're developing that sense of number, they're quantifying, they're subitizing, all those number sense, critical number sense skills that they develop at a very early stage. We present them with the concretes so that they can manipulate, not negating the fact, like I said, there are many things in the environment that we can use for them as well. The Lego blocks, the abacus, the 10 frames, and you'll see some of those things popping up as we go along. The clock, counters, the 10 frames, dominoes, cards, the number line that tends to be underutilized sometimes. So these are some of the tools that we can use to build number sense at a very early stage. So in terms of building number sense, what are some of the things that we can do? Real world problems. What do we do? Connect math to everyday life. Again, I'm going back to the icebreaker. By creating problems based on familiar scenarios that are relevant to those young learners. So we don't want it to be out of context. What are they bringing into the classroom? What are the prerequisites that they have? Where are they coming from? How can we meet them halfway so that they don't get lost in solving those problems? Or we can also have them to problem pose, where we ask them to create their own problems as well. Playful interactions. Based on child psychology, we know children at a very early stage, they dabble with the concrete because that's psychologically, that's where some of them are functioning. So the use of songs, the use of jingles, the use of games, playful interactions, integrating physical education with the different subject areas, science, experimentation, all of those things that we can make fun and engaging for the students as they build number sense at a very early age. And rest assured that those students will remember those things because we are tapping into their experiences. We are also tapping into what they love to do, which is play, whether structured or unstructured. Math puzzles and games. Again, integrate age-appropriate puzzles and games that would stimulate critical thinking and problem solving. And we know that puzzles have the ability to do that for our students. Puzzles in particular build that level of spatial sense. So students know where and when to put certain things together. And of course, guess solve theory, the sum of the parts is equal to the whole. So at an early stage, we are presenting to those students that we want them to not just see numbers as abstract, 1 as 1, 2 as 2, but we want them to see that math is in number sense is in the geometry, it's in the measurement, it's in the fractions, it's in everything that they're learning. Calendar math. So again, some examples. The calendar, daily interactions, daily lived experiences. The students are seeing the calendar. It follows a sequence. It can be used to teach counting. It tells them that time is passing, time is not standing still. Today is the 23rd, tomorrow is the 24th, today is the 1st, today is the 23rd, yesterday was. So you're teaching ordinal numbers, you're teaching sequence, you're teaching increasing and decreasing patterns. Okay, and some of those fundamental skills that are necessary can be taught using a simple calendar. Story problems. Present word problems through stories and encourage students to retell the story in their own words to build comprehension. And this is critical. This one is critical. I hold it very, very dear to my heart as an educator because we are seeing where we are losing some of the kids, their inability to comprehend, to paraphrase, to state things in their own words. Maybe it might be a phobia for the mathematics, it might be anxiety, but giving them those opportunities to speak. Again, we are bringing across the use of the language at skills. I'm heavy on the integration with language. Allow students to speak, have those mathematics talks, those walks, let them see, let them experiment, let them talk, let them tell you why, the how, let them justify. So with the story problems, we are allowing them to speak, we are allowing them to state in their own words, just to test for comprehension. And again, we have the class math corner. Bringing things from home, the empty cereal boxes, let them bring in their cars, all those different things to create a math corner, a classroom that is lively, a classroom that students would enjoy interacting with. They can independently go to the corner and do engage in some independent work after they have completed their work, but not a classroom where everything is just, for want of a better term, a dance hall. All the walls are bare. There are no corners. There's nothing for the children to interact with. We're talking about the little ones in K grade 1 and 2. I'm heavy on those corners where students come to school to enjoy mathematics and they're seeing the relevance of what they're learning. It doesn't have to be expensive. It doesn't have to be all those fancy manipulatives, all those fancy things, but it can be things that the kids can bring in to actually manipulate and share. All right, just a sample here for you, all about me in grade K. What are some of the things that you can do with a child as you build number sense? We're not just teaching them to count. We're not just teaching them to identify a numeral. We're not just teaching them to quantify, to state that 1, 2, 3 is 3. We want them to connect and to have that appreciation for what they're learning. So when they step out of the classroom, they have that appreciation of number at a very early stage. So what can we do, especially for K class? It can be used with grade 1, grade 2. How many persons are in your family? And you have right there integration with social studies. What is your age? That's a numerical value. What is your date of birth? You have a month, you have a date. If you have pets, how many? Shoe size. What year were you born? What are your parents' contact numbers, which is important at this stage for a lot of our kids. Your parents are driving, what's the number plate? You're in the schoolyard, teachers have vehicles, can you read a number plate? So students are seeing numbers everywhere. And all about me, number book. And what this can do for the students, they can personalize it with pictures. So the students are enjoying what they're doing, they're personalizing what they're doing, they're able to connect with what they're learning, not just the school, but the home school connection to recognize that, yes, I have that sense of number. This is what I have learned and I can apply it beyond the walls of the classroom. So number sense at a very early stage for our students, it's critical. All right. This was supposed to be a poll, but anyway, yes. Just place in the chats, just for knowledge, where do your students struggle the most? A, B, C, or D? Is it identifying place value of whole numbers? Is it with addition or subtraction without regrouping? Is it regrouping with addition and subtraction? Or is it decimal operations? So you can put one response or you can put more than one. It's up to you. All right, so where is the struggle for those students? And as we move along, of course, we discuss, we express. All right. I'm seeing C and D, C and D. There's a lot of C's. The regrouping, the regrouping. All right. Okay. All right. We have a spread. A, B, C, D. They are all challenges for our students. And again, it all stems from the number sense, building number sense at an early stage. So when we get to that point where we're learning place value, we're learning addition without regrouping, addition with regrouping and subtraction, decimal operations, how can we jump over this hurdle to combat some of the issues that students have with learning those? So thank you for sharing. Thank you for sharing, colleagues. All right, we shall move along, if you permit me. Okay. All right. So my question to you, just a little bit of reflection as we delve into Base-10. Did you know that Base-10 is also known as the decimal system and uses the 10 digits 0 through to 9? Did you know that each digit in a Base-10 number has a place value based on powers of 10, starting from the rightmost digit as 10 to the power of 0 is equal to 1, and then you have 10 to the power of 1, which is 10, 10 to the power of 2, 100, and so forth, which gives you your place value system. The value of a digit equals the digit, the value of a digit equals a digit times its place value. For example, in 345, the 3 has a value of 300 because it is in the hundreds place. Did you know? Base-10 is a positional numeral system, meaning the position of each digit determines its value. Did you know? The Base-10 is derived from humans having 10 fingers from counting. A bit of history here. Did you know that decimal fractions extend Base-10 to values less than 1, where the first digit to the right of the decimal point represents tenths, or 10 to the negative 1 power, then hundredths, and so forth? And did you know that Base-10 is the most common numeral system used worldwide in everyday applications such as counting, measuring, and financial transactions, measuring conversions from one unit to the next, the stock market and all of those things. That is where our Base-10 numbers, the applications are there. All right. Again, creating the image for you, graphic organizer. These are how some of the concepts, it's not exhaustive. Some of the concepts, how they are interwoven into the Base-10. How important it is to learn Base-10, the importance of having a solid foundation in Base-10, so that some of those concepts that you're seeing cyclical on the diagram, how learning about Base-10 impacts them. So we have reading and writing numbers, knowing about whole numbers, place value, performing mental operations and mental calculations or mathematics, number operations, the concept of area, decimals, the distributive law and how the distributive law actually is interwoven in the concept of area, and counting. So there are a number of concepts. This is what impacts a lot of those concepts. And we know with what you posted in the chat earlier, not too long ago, that if we do not solidify this early, the decimals is going to be a problem. The addition and subtraction with the addition and subtraction of whole numbers with regrouping may be a problem. Again, if it's taught well enough, it can be eliminated. And there are various strategies that we are going to explore shortly in terms of how we can actually teach addition with regrouping without going through the traditional method. So stay along with me. All right. So we have some other concepts of math that Base-10 hinges on, and we have fractions, percentages, area, volume, perimeter, comparing numbers and rounding off, and of course in building numbers. So I'm placing before you, and you realize I keep on putting the photos, the graphic organizers, to give you a picture, bird's eye view as to how this thing is connected. So we have everyday situations for number. We do reading and writing numbers with the students in, let's say, the first term. We do place value in first term. We do all those number concepts in the first term. But then when we get to term 2, we are looking at reading and writing sums of money. Why not do it right away? It's whole numbers we're dealing with. The only difference is the use of the symbol. So how do you feel a deposit slip? Fast forward, rewind back to the icebreaker. Okay, simple. Deposit slip. How many $100 bills? How many $10 bills? How many 10-cent pieces? How many 25-cent pieces? Your deposit slip. You're going to deposit money. Can you read a number plates? Generally, we as Caribbean people, we read the number plates PE 3312. But it's a 4-digit number with the 4 digits close by, PE 3312. Then we'll have a receipt. We go to the supermarket, we shop. Can you read the prices on the shelves? Can you read your receipt? You buy one item for $1.99. You bought 2 of that item. What is the price? You're doing some mental calculations. You're doing some estimating as you go ahead and you shop. Did you have enough money? So your receipt will give you, yes, I did not overshop because I actually went in to get what I had to get and I paid for the right amount. So we estimate. So a number of mathematical skills that speak to number and everyday situations that we encounter. Then there are some specials. Some of us wait for the sale and the specials from the supermarkets. Save $10. You have a reduction. You have a discount. Okay? And of course, some of us, we use our checkbooks. The amount of money has to be written on the check, both in words and in figures. When you fill out that check, you also have, the check also has a stub with a number. You also have to key in the date. Here we go again. Numbers, numbers, everywhere. Building number sense. It's not isolated. So from number sense, from blocks to brilliance, and building number sense with Base-10 tools. And where are the tools? The tools are found in our environment right there before us as we navigate life's daily routines. All right. So for the little ones, there is a manipulative that we normally we recommend. Oops, somebody is writing on my screen. Okay, so this is what you call the 10 frame. This is called the 10 frame. And for the little ones, it's something that we recommend. We have the 5 frame, we have the 10 frame. The 10 frame helps the students, the children, the 6 and the 7-year-olds in grade 1, as they start to build the concept of tin numbers, as they start to build the concept of place value, ones, tens, numerals up to 20. So it's an interactive tool. I'm just showing you because the hands-on. So what do? We can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you want them to see the difference between the 2 frames, we can color coordinate 10 and 1, 12, and you reinforce a group of 10. How many in there? 10
Excuse me,
squares.
sorry for butting in. You cannot see the hands, but they cannot see the tool. Nothing is showing on the screen.
There's nothing on the screen?
No,
Oops.
no.
Sorry. Thanks for letting me know. Okay, I'm not sure what's happening there. Just give me a minute. I think I know what's happening here. Okay, yeah, I have to come out of the... You can see the screen, right? Okay.
Yes, we are there now. Great.
All right, awesome. Okay. Okay, so let me just backtrack. All right. Okay, so I was saying, so this is your 10 frame, right? And again, the frame, rectangular in shape, you have your 10 mini squares in there. All right, so we are teaching them groups of 10. So we're counting. I need you to fill out your squares, all the squares. How many circles or how many counters did you put in there? We're counting 7, 8, 9, 10. Then we are going to add another frame, or I'm going to give you another frame. Okay? How many do you say is in here? 10. How many groups of 10? 1 group of 10. And you have to reinforce as we teach them the Base-10, the transfer from 10 to 11, 10 and 1, 10 and 2. It's constant practice, constant manipulation, constant visuals so that they understand. 10 and 1. What number do we have here? 11. So we're teaching them the tin numbers. 10 and 2 gives us what? 12. 10 and 3, what does it give us? Or 10 plus 3 gives us 13. So they're seeing that 10, group of 10, and 3. So that's where we start it off with them, using the 10 frame. It can be the virtual tool, or I'm reverting to the slide. Sorry. Or it can be whether you have the magnetic 10 frame or you have it drawn on paper, You can use stones, you can use counters, whatever can fit within the square so they understand the concept 10 plus this. And of course, we're doing the number families with them up to 20. All of those things, it help to build the number sense and solidify for the students the path we're taking them down, 10 and. So you deliberately presenting to them that frame, 10 and, 10 and you're counting, and the numbers are increasing 11, 12, 13, your teen numbers until you get to 20. All right, and that is where we end off grade 1. We can also, okay. Okay, the slide. I'm not sure what's happening here. Give me a minute, a few seconds. This thing is not cooperating. Okay, I'm not sure what's happening here. Okay, let me take this on again. All right. All right. Screen is visible. Okay. I'm not sure what's happening here. Okay. Yes. So back to the 10 frame. Now, again, we are connecting. I may have put the cat before the horse there, but it was deliberate because the 10 frame is something that we use. But even more importantly, there is something that the students are familiar with. Everybody loves money. Everybody loves money. Why not use the concept of money to reinforce the 10 frame thing and the base 10 that we want them to learn in terms of place value? $10 and $4, 14, and we're going back to the 10 frame. So the $10 is that one group of 10, but $10 in exchange for the 10 coins. So they're saying that this is the realistic thing coming there to life in terms of what we want them to learn at that stage. So instead of just using the numerals abstractly, we are now connecting for the students that yes, we're learning about the 10 frame, but the 10 frame can be likened to learning the concept of money and grouping. 1, 2, 3, 4, 5, 6, 7, 8, $9, $10. I can give it to you in exchange for $10. One $10 bill. And we have it right there. We're taking them into the place value. Yeah? One $10 bill and $2 coins. That gives us $12. And they do the amounts first, the 19 and the 20. So yes, the use of the frame, the use of the interlocking cubes might be a bit abstract because sometimes the hands-on can be a bit abstract for them, but we have an opportunity to present this to them that they're doing the exchange. Yes, I have $10 coins, but yes, I can now regroup it in exchange for that one $10 bill. And then that's takes us now into our placement of the values. All right, and with the 10 frame, we can get to that point, the representation using a worksheet, one group of 10, 2 ones, and so forth for consolidation when we get to that point after they have had enough experience with manipulating the concrete before we get to the visual and the abstract, where we ask them 12 is equal to one group of 10 and 2 ones, not just 1, 2. But they understand is one group of 10, 2 ones, and you can have them to draw to represent those values. All right. Again, We are building, so the standard form. So we have some terms here when we teach the students. So the numeral 25 is called the standard form of the numeral. So as we teach the value, when we teach the base 10, the element of the base 10, standard form 25, that's how it's written. So the numerical written value that we see, the numerals, that is your standard form. Then the worded form, of course, is the letters, the words that you assign to the standard form. The base 10 model, all right, it can be a pictorial representation. It can also be hands-on. Let me just punch in there for you. It's recommended for the grade 1s and 2s that we use interlocking cubes, and you will see what they look like shortly. The base 10, the base 10 model, they represent those cubes. So it's easier for the students to manipulate those. So your group of 10 and your 5 units or ones. In expanded form, we want them to add. They have learned to add. So how do we now bring it all together? One group of 10, one group of 10, one group of 1, 5 times. What does it equal to? They've learned to count by tens. So 10 and 10, 20. And we have 5 units, which gives us 5. So everything is coming together. And if you want to show the connection for them as well, okay, we want them to represent 25 using money. There we have it. We have 2 $10 bills and we have $5 coins. Okay. So we have the unifix cubes. Again, you see the structure of the cubes. Each cube, each color has 10 cubes. So as we teach them the base 10, we use that tool. When the child has stacked up those 10 purple cubes, they realize, now I need an exchange. I move on to the next one. So one group of 10, another group of 10, another group of 10. So this in essence helps to solidify when they're learning the placement of the numbers, identifying the numbers, how to formulate the numbers from ones to tens, up to 100, grade 1, grade 2. So this is it. That's a sample. All right. So we have 1, 2, 3, 4 tens. So they're seeing groups of 10. Now the color, these children at that stage, they're attracted to the color. They love the color. They're able to visualize, and they're able to put the groups easier and see them easier with the color. One group of green with 10, orange, blue, and brown. And then we have three individual units here, or free ones, to give us 43. So it's easier with this for them. So the recommendation is for grade 1, grade 2, if we have them. And of course, there are other tools that can be used to bring across the concept as well, which we will see a little later. All right, so this is what's recommended. All right, in terms of misconceptions with writing numerals, we know that our students, the placeholder 0 can be very ticklish for them. For some of them, 0 means nothing, but it has its place. And that's one of the errors that they continue to make when they're writing and reading numbers. The position of the digits, sometimes it confuses them how they read. 349, 246 instead of 300. And of course, instead of reading the digits, or in terms of the place value, is just the face value that's been made mention of. So again, having that knowledge of placement of numbers, place value, the base 10, the manipulation of those concrete items will help solidify and and also possibly eliminate some of those misconceptions. And of course, we know the regrouping, or what we call carrying over, right? 45 and 26, instead of writing the 61, they give you 51 because their inability to see conceptualize the value of the digits based on their position when they operationalize. So these are just a few errors. So I think this is what you've been waiting for in terms of the base-10 blocks, also known as the DINS blocks. How do we use them in the classroom, again, if we have access to them? And what are the alternatives for using base-10, identifying or solidifying the base-10 theory as we teach? So if you have those, actually it makes it easier when we saw the graphic organizer in terms of the number of concepts base-10 can help solidify if we teach it from the concrete phase. So we have the units, these are our blocks, so the units. So each one represents the numeral 1 or the ones place. And every single one of those small blocks has a dimension of 1 by 1 by 1 centimeter, which is actually a volume of 1 cubic centimeter. This here, we call them rods. Each rod, it represents the numeral 10. If you count the number of rods in here, of course, the volume is actually 10, and the volume speaks to the place value. So we have 1 unit by 10 by 1. So when you actually calculate the volume, 1 cm by 1 cm by 10 cm, it gives you a volume of 10 cubic centimeters. So the rod has a volume of 10 cubic centimeters. So we are now connecting the base-10 blocks to the concept of volume. So instead of just telling the students about volume, there is an opportunity for them to see what volume looks like using the base-10 blocks. Then we have the flats, which represents the 100 place value. Again, we're looking at dimensions. So we have 1 cm by 10 cm by 10 cm, or what would normally tell the children length by width by height. Again, if you count all those squares here, you actually have 100 cubic cm, 100 cubes within this here. So it's actually 10 of those here that make up the flats. All right, so we've seen the progression. We are increasing by 10. Then we have the cube in here, which represents the next place value, which is 1,000. And we have 10 of the flats here represented. And each of the flats has a dimension of 10 centimeters. Again, length by width by height, which would amount to 1,000 cubes or 1,000 cubic centimeters. And if you were to add all the cubes within this here, you would actually get your 1,000 cubes. So again, the concept of volume, even surface area, perimeter, all in one. So we have our place values based on the base-10 blocks. Units, or 1, tens, hundreds, thousands. Okay? And of course, we know what's going to happen the next stage. So if you have 10 of the cubes, because you realize we're increasing by 10, and then you have to do the trade over. All right, so we have a sample here, building numerals using base-10 blocks. As you can see here, we have 1, 2, 3 units, 1, 2, 3, 4, 5 rods, and 2 flats. So put this number in your head. 3 units, 5 rods, 2 flats. And I will take you to, doesn't pose a problem. I will take you to an interactive tool. Can you see my screen? Yeah? All right. So what this tool does, I'm just hiding my face a little here, sorry. just to show you what happens with the base 10 blocks. So we're counting and you're seeing it increasing on the screen.
Excuse me, please, miss. We are not seeing the site that you're on. We're still seeing the PowerPoint.
I came out of the PowerPoint. I'm not sure what's happening. Can you see my screen? Can you see my screen?
We're still seeing the PowerPoint.
And I have exited it. I'm not sure what's happening. Hold on. Hold on. All right. Let me share again. Can you see now?
It's coming up.
It's coming up? Okay. Yeah.
Seeing it now.
All right, great. Thank you. All right. So we're looking at, we are going to observe what's going to happen. So we're counting the numbers. How many ones? 1, 2. So we're forming the numeral. We're forming the numeral here, right? So that's 4 ones, 5 ones, 6 ones, 7 ones, 8 ones, 9 ones, and let's see what's happened. Can we have 10 ones here? Let's see what happens. You saw what happened here? So now we have a trade over. So 10 ones is equivalent to 110. The same thing is going to happen if I put my 10 tens here. Let's see what happens. And you're seeing the increase. Okay. And of course, the number as well. 6 10 0 ones, we know it's 60. So we have a trade over for 10 tens for 100. And the same thing is going to happen if we have. So it's something that you can use with the students for them to actually see the trade over. So as you manipulate and you do all of these, the hands-on with them to solidify the concept, we can use the virtual so they're actually seeing that there is a trade over. We cannot keep it. Why? Because it's 9 digits that can fit into that place value. All right. So we just traded 10 hundreds for 1,000. All right. And we can see that's equivalent to 1,000. So you can create any of the numbers there. Okay. So I have 1,000. If I put 200s here, you can see it's changing. Right? 110. Okay. 1,200, 1,211. So it's an interactive tool that we can use after they have manipulated those base 10 blocks to understand what's happening with the number and the trade over. Why? Because the 0 to 9 digits are what needs to be placed in any one of those place values. We cannot put a 2-digit number in there. So that can help solidify what it is that you're learning. Okay. So all of this is in there for you. I'm back to my presentation. All right. All right. So again, money comes up again. We love money. The numeral we're representing was 253. Again, there we go. $3 bills.
Excuse me, please, miss. Sorry to cut you off. We're still seeing the sites. You need to switch your presentation back to the PowerPoint.
It is on the PowerPoint. I'm not sure what's happening. Okay. I will stop share and I'll go back again because it is. All right. Thanks. All right. Can you see? Can you see?
Yes, we can.
Okay, wonderful. All right. Yes, so I said back to the money again, making the connections between the actual numerals you're learning about, but presenting it within a context that they can identify with. 253 as a numeral using base 10 blocks, 253 using money. $3 coins, 5 $10 bills, 200 bills. Okay? Now, for the next few slides, I believe this is the number that's going to be popping up so that you understand the transition. Okay? So, place value chat. So, hands-on, hands-on, hands-on. Concrete, concrete, concrete. Pictorial, right? And you ask the students, they can draw it, or they can place the base 10 blocks within the sections. And one of the recommendations is that when you're teaching this, ensure that the students have, each child has a place value chart, teachers have their own. This is something that sometimes we tend to draw it on the board, but the students need to see it for themselves and the manipulation. All right, so we have free ones, we have 5 10s or the 5 rods, the 200s. What does it look like? So again, I'm taking it piece by piece. 200s, 100 plus 100, the 5 10s, 10 plus 10 plus 10 plus 10, and the free ones, 1 plus 1 plus 1. 200s, 200, the 5 10s, 50 we're counting, and the individual units, 3. So we have our expanded form, 200 plus 50 plus 3. The standard form for that, when we add those values, 253. Just a slight error there. The 253 is not the expanded form. The expanded form is the 200 plus 50 plus 3. Okay? It's just to show you the graduation in terms of how everything builds up. Okay? Then we have this representation. Our concrete, which can also here be a visual as well, the pictorial. This can also be pictorial. It depends on the level of manipulation. So your concrete can be the pictorial. It depends on how it's represented. So if they're manipulating the money, it becomes your concrete. If they're manipulating the base 10 blocks, it can be your concrete. If you are doing a diagrammatic representation, it will be your visual or your representation. All right. And then, of course, it all comes together here where you have your standard form again, the worded form, 253, your base 10 model, expanded form, and the direct translation to something that the students experience every day, playing with money. All right. So, question. We have manipulated the blocks. We have understood the blocks. We want to teach the students to be fluid with numbers. We want to now drive the point home. Do you have number sense? Do you understand the concept, the relationships that exist between the numbers? So we're taking 253. We know it's 200s, 5 10s, free ones. Do you know that 253 can be 25 10s and 3 ones? Do you know that 253 can also be expressed as 100, 15 10s and 3 ones? Or do you know that 253 can be 253 ones? So as much as we teach the students with the base 10, using the place value charts, we need to go a step ahead. We need to let them see the connection between the number operations, the division. How many 10s do you have in 200? How many times can 10 go into 253? Will there be a remainder? So you're asking them questions. You're asking them to analyze the number put before them. So I have understood the place value system. The extension now is, am I fluid with the number? Can I go beyond just the knowledge of place value? And this is what this presents to you here. All right. So sorry for the instruction. Can you do this for me? Not using the conventional 10s, 100s, 10s, ones, but what I just presented to you a while ago. So in the chat, 329, can you express it just, well, for you in just one way? All right. Represent 321 or express it in one way using an expression as I presented to you over there. So I don't want 300 plus 20 plus 9, but something else. All right, so have a go at it. All right, so we have some answers in here. 329 ones, 42 tens, 9 ones, 40 tens, 29 ones. Yes, you're getting the idea. All right. 200s, 12 tens, 9 ones. Excellent. Okay, yes. So this is something that we can do with the students. Again, once they have understood the concept. So building on that, now we're going to take them to the next level. And that is where we're tying in from the blocks to brilliance, building number sense with Base-10 tools. So we have to understand, they have to understand that concept before we can now challenge their thinking. All right, so thank you for your responses. Okay, all right, so here we go. Just for you to have a think at it, reformat, rethink. We are now rethinking in terms of how we represent numbers. 2,000 plus 40 plus 6. That's what we'd normally do. 130 tens plus 16 ones. The students are now seeing numbers in the different lights. 1800s plus 5 ones. There we go again. $1,900 bills plus 30 $10 bills. What is that value? Again, application, connection to what they experience. You're counting money. You can give them they can draw the bills and count how many 19, how many 30 for those who are probably having some challenges, and to count it to give you that total. So rethinking, reformatting how we present those numbers to them, because we want them to be fluid with the numbers. All right. So I just have for you some samples. To be quite honest, I don't like to use problem solving. I have asked our teachers here to rename and reframe to number stories, because just problem solving is like it has a psychological effect on the students. So number stories, because it's a story that they're reading and they're trying to find a solution or an end point to that story. All right, so here's a sample. It's taken from one of the books, 180 Days of Problem Solving for 4th grade. So use the information from the table to write the number. Show how you found the answer. Okay, so one strategy is presented here. So 1500s is 1500s, 12 tens is 102 tens, 26 tens is 2 tens and 6 ones. And therefore the final answer would give you 1600s, 4 tens and 6 ones. So again, breaking it down for the students, giving them that opportunity to see numbers in a different light. So that's one sample. Then you have this. 2 friends are playing a board game with pretend money. The game has paper bills printed with $1, $10, 100, or 1,000. Player 2 lands on a space and must pay player 1 10 times the amount of money in player 1's bank. Player 1 currently has $249. Which bills can player 2 give to player 1? Again, give them a situation where they can draw, where they can manipulate, whether you want them to use the place value chart in order to find the total value of what the problem or the story is asking them to come up with as a solution. All right, so we can present situations to the students where place value, where the Base-10 is concerned. Then we have this, it's almost like a little riddle here, right? So you have the letters and you have the values. Write each number in standard form and in expanded form. You use the expanded form, write the letter that matches the value of each addend to solve the riddle. So our addends are these here. 1, 2, 3, 4, 5, yeah? And then whatever value here, you go up here and you select the letter that corresponds, and it will answer the riddle which asks what type of angle is never wrong. So that is another type of situation you can give the students to get them thinking about numbers. And I think that's the last one. 2 students, again, error analysis. So it's not just giving them a straight path to get to the answer. Present errors, give them the error analysis, have them to explain and justify why the answer is inaccurate, or if it's accurate, why. Okay, so we have here 2 students are given a number in expanded form. They rewrite the number in standard form, identify each student's mistake, and of course, the follow-up to that is, how would you correct it? So we give students those opportunities as well. As much as we want to teach them about the numbers, how we derive numbers, place value, and manipulating numbers to be fluid and flexible with them. But at the same time, we also want them to reflect on someone who may not have it always accurate, and to actually provide guidance. So we can do pair tutoring and so forth. And that's one of the strategies that we can use for that as well. Or you explain to the class why, and you justify. So in terms of alternatives to Base-10 blocks, if we don't have the Base-10 blocks, there is always this route. Whether we have the number discs or you have paper and you write the numerals on it, or the students write them in circular format or whatever shape that you choose, these can be used as well. All right. The Lego or building blocks for the little ones, they always have blocks that can be substituted for the interlocking cubes. DIY, buttons, bins, the craft sticks, the popsicle sticks, you can't go wrong with that. I remember as a primary school teacher, you just could not go wrong with popsicle sticks, and rubber bands. All right. So if you don't have the Base-10 blocks, whatever would represent would suffice. All right. And just to remind you that it is not one of the most easiest concepts to bring across to students, but through mass practice, through constant manipulation, through concrete examples, through connections, through situations, ensuring that the students can see, they can touch, they can manipulate, move around, using, if you have access to the virtual aspect of it, let them see what is happening. It's not something that is one shot. We have to ensure that we engage them, we manipulate. All right. And of course, the alternatives, like I said, the virtual manipulatives, number lines and 10 frames, which we came across earlier, counters and small objects as well. And of course, we have to be aware for the small objects for the younger ones to ensure that they don't put them in the mouth and create a problem. All right. So we now understand. We have understood place value. We understand positioning of numbers. We can now read and write numbers. We know what expanded form is. We know what standard form is. We know how to put the numbers, the add-ins together to bring everything together to give you the standard form of the number. How does that now apply to addition? Okay, simple addition, no regrouping. So we have the number 1,124. You can see the little blocks there, right? So that's this one, and 100, I should have brought it down, and 33. When we combine everything together, like it has been combined for you, we have 2, 4, 6, 7, 7 ones, we have 5 tens, we have 200s, we have 1,000. What does that amount to? 1,257. Simple, straight representation using Base-10 blocks. A child has difficulty adding with no regrouping, tell them to use the diagram. That is, if you have exposed them to a group of 100, a group of 100, or they can, and you will see how it can be broken down further. All right. The ticklish part now starts here, where we ask them to regroup. What happens now? Again, 58 plus 64. So right here, we have 50, we have 8, we have 60 or 6 groups of 10, and we have our 4 ones. Let's see what's happening here. We have 4 ones or 4 units and 8 tens. That's 12. We have a problem here because we know our digits cannot fit in here. So I'm giving you the hands-on approach to manipulating Base-10 blocks. So step 2, what happens? I know I have 12, so I know I have to group because I've gone beyond the 9. So I have my group of 10 here, and I'm left with my 2. What happens? We're going to circle. because we know we have a group of 10. What do we do with this group of 10? We are now doing the trade over for one group of our rod of 10. So we have now done that transfer here, and we are left with our 2 ones. With me so far? So let's see. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tens, 12 rods. Again, we have a problem here because we cannot have any value here that goes beyond 9. What happens next? Again, we regroup. So we know we have to group our 10, one group of 10 here, 2, 4, 6, 8, 10, right? We have regrouped, and we know what's going to happen here now. We're going to trade off. That one group of 10 amounts to what? 100. So we're now going to trade it off for one group of 100, and we are left with those 2, which you see here, 1, 2. All right? So we have 2 ones, 2 tens, 100, sorry, which amounts to 122. One group of 100, 2 tens, 2 ones, amounting to 122. Not being read as 1, 2, 2, but the groups that they represent. All right? So the use of the blocks, that is how we can do the regrouping for the students. Let them manipulate. And again, it all starts with reading and writing numbers, place value, placing the numbers, doing the trade-off, the mass practice. So when they get to the addition, it should eliminate a bit of the stress for them. Hands-on manipulation. This is what we're accustomed to, the traditional way of addition, where we tell them add 4 plus 8 to give you 12. We tell them cross the 2, put it in the ones place, then we move on to the tens column, 6 plus 5 plus the 1 to give us 12. We got the same 122, not so? But that's where we normally jump to with them. Bear with me. We have the option here of what we call friendly numbers, and that's where the mental arithmetic come in. Again, fluidity with numbers. Can I get to the next decade? So I can break off, I can form a number bond here for 58, 6 and 52, right? So I'm now going to add that 6 to 64 to give me 70 and add 52. I have a expression here that does not require regrouping. If I put it vertically, I simply have 70 plus 52 to give me 122. There is no regrouping happening here. All right, so the use of friendly numbers, and this is one of the mental strategies students can use as they add numbers with regrouping. Again, these are skills that we have to teach them. Again, sorry, and of course, alternative ways of adding with regrouping. That's basically what this speaks to. Then we have decomposition. You may look at it and say, boy, this looks challenging. Why would I teach a child that? 64 plus 58. These are the 2 numerals. Again, I'm saying we're using the same expression. Knowledge of place value, knowledge of breaking the numbers down. 64 is 60 plus 4. 58 is 50 plus 8. I group my decades together, or my groups of 10. 60 plus 50 gives me 110. 4 plus 8 gives me 12. And of course, this one is pretty easy to add, or I could have further broken down the 12 into 10 plus 2. A decade of 10 plus 110, 120 plus 2 give me 122. Again, based on your interaction with the students and how you have solidified the concepts for them as you take them through that phase. Then we have vertical addition. So you're seeing, are you with me so far? You're seeing how important Base-10, teaching them the understanding behind the place value, how important it is for number operations. So again, we have 64 plus 58. We can go, we normally tell them go from right to left. Not so, but we can go from left to right. 6 plus 5. It's not 6 and 5, based on place value, placement of numbers and values of digits within the number. We have 6 tens, 5 ones to amount to 110. Then we have 8 tens and 4 ones, which give us the 12. We add those values and we get our sum of 122. So I have given you different strategies for adding, taking you from representing the numbers concretely using the Base-10 blocks. The child can choose to draw the Base-10 blocks to represent the operation that's being done here. Or the child can, if you expose them to these and they have understood the numbers, they can do this without the stress of all that regrouping, adding vertically. Once we have concretized for them the purpose for learning place value, the purpose for identifying values of digits, the purpose for introducing them or having them to manipulate the concrete before we transfer or we transcend to the abstract. Okay. All right. So that brings us to, you have some tools here. All right. In here, some of the virtual math manipulatives that can be used for Base-10. All right. Out of all of them, this one really appealed to me, the Base-10 blocks on ABCA. All right. And showing you the actual regrouping taking place every single time. All right. And as I wrap up my presentation, I would like to leave this with you. Blocks are not brain tools. Sorry, blocks are brain tools, not baby tools. So sometimes you hear teachers say, why a child in grade 4 or 5 have to be using manipulatives? It helps them to process, it helps them with conceptual understanding, it helps them with relational understanding, it helps them with going through procedures. So the age at which the students are does not matter which tool that you use. Sometimes you have to go all the way up to grade 6 to solidify the concept of place value, especially if there was a gap in their learning throughout the years. So blocks are brain tools, not baby tools. So let's use the blocks, from blocks to creating brilliance in students, building number sense with Base-10 tools. So as I leave with you, think like a child to teach and reach a child with mathematics through interactions with the concrete, taking them from the concrete to the pictorial to the abstract, making connections with the experiences within the walls of the classroom, bringing in the experience so we can now be like the children, have fun with them, give them the games, give them the experiences so that those concepts can be solidified. All right. So what I need you to do for me now as we reflect based on what was presented to you, one way in the chat, you will use Base-10 tools differently after today. If this has stuck a pin for you this evening. All right. One way you will use Base-10 tools differently after today.
Thank you very much, Ms. Giffard, for such an engaging and practical presentation. I think we can all agree that using tools like Base-10 blocks, the Dean's cubes, the interlocking cubes, etc., to build number sense really does take us, as the theme says, from blocks to brilliance. I know that you have put out a lot of energy, but we still have the question and answer section. So at this point, yes, we want to just open the floor for your questions and reflections, participants, because we must say to you, thank you so much for your engagement. Let's really appreciate Ms. Giffard for the presentation and the engagement that we just saw. We appreciate you. We appreciate the work that you do and the scholarship that you bring to mathematics education in the region. We have at least one question that was in the chat that I've noted, and we want to just take a few minutes. It's not going to be too long. And I want to recognize that we have stayed at over 240 participants for an hour and a half. So that is amazing, everyone. And that is testament that you know, you didn't waste your time in being here. So thank you so much. We have a question coming from one of our attendees. They asked, how do you ensure that the students don't get confused while expanding the numbers? Which concept should be taught first? So you were looking at, you know, the different aspects relating to expanding, and this person in that moment, I'm just repeating the question. How does a teacher ensure that the kids don't get confused while expanding numbers? Which concept should be taught first? And if the person who asked the question is still here and you want to clarify your question a bit more, you know, feel free to do so. Ms. Giffard?
Yes, she was speaking about the different ways of representing a number. So I want to know if we should teach first the standard form and allow them to represent the number in different ways, or vice versa, because they could get confused. I see it as they could get confused if we represent the number in a lot of different ways and we come back and we say, we are expanding the number now. The child might just write it in a way that is not suitable for the expansion. You understand? So which one should be taught first?
Okay. You're talking about the graphic organizer where I had standard form, expanded form, word form. That's what you're referring to, right? Yes.
I'm talking about when you said, can we represent, like you said, 329. Can we represent it in different ways? So the thought came to me.
That's what you're talking about.
Yes. The thought came to me that if we do that with the kids before, and then we go back to say, let us expand the number, they just might give you that same sort of answer that they give before.
Okay.
So I'm saying, should we teach them standard form first and then go ahead and do that? The methodology of both can confuse them, and we have to keep on saying that you are right, but it's not that I want that this time, you know, to avoid that.
Okay. You would teach them the expanded form of representing the number based on place value. Now, what I brought in there is basically for the students to play around with the number, because it's connected to the concept of division. So instead of telling a child, what is 329 divided by 100? How many hundreds can you get in 329? So they understand the expanded form format. That is a given. 42 tens, 9 ones is not the expanded form. The expanded form speaks to 300s, 2 tens, 9 ones. But the extension to see whether they have understood. I understand where you're coming from, because remember, you cannot have any numeral greater than 9 within that space there. But just to ensure that they have understood and they're fluid with the number now, and they have understood, yes, I understand place value, I understand value of digits, I can write it in expanded form, I can write it in the standard form, but the extension, you're just going beyond them knowing about numbers. Okay, but it's not for place value per se, as in a place value expanded form format, but for representing that, yeah, I can get 49 tens from it and I can get 9 ones or 329 ones, but it won't fit within the format of the place, the place value chats that we would want to. I hope this answers your question. Yes, so I understand it can cause confusion, but in terms of placement for expanded form, no, we would not use that. It's just to go beyond the understanding of the number. All right.
I have
And it will
another.
help. It will help with division when they get to the point where they're dividing numbers, they're doing fractions, they're doing decimals. It will help a bit. Yeah.
I have another question. We talk about maths in everyday life, and
Yes.
we know we have a curriculum, and we know the curriculum have a limit. Even coming from a preschool perspective, we might have 1 to 5 that the children will do the number, the value, and everything. But the children will do the calendar every day, and they are very curious. So they know that which number comes after, what number comes before, and they can play around with it. Just as we had the everyday life, and a child would see on the car, on the what do you call that part of the car, the number, I think you had 133 something. No.
Yes, the number plates.
Yes, big numbers, large numbers. How do we grip, just by identify, a child might say this is a 2, this is a 3, this is a 9 in the number from preschool. But they might meet a place where mommy want to explain to them that this is a $50. This here is a $50, because sometimes the child might have given a peer or somebody a $50 for $5 because they like the color green. Yeah. So the green is the $5, and the child will give the $50 for the green one. How do we explain to children, or do we limit them when it comes to concept like mathematical concept like that? Do we explain it to them, or do we limit them? Because I find lately that we seem to be saying that we don't have to go past there, and the children are curious. And we tend to, that hunger for learning, we tend to kind of dampen it, because we say it's above the child. And I don't think anything is above the child once the child is curious. So what do we do in those situations?
That's a $1 million question. To be quite honest, as you probe the child, you know if the child knows, or if it's just basic procedural for the child. The questioning would give you an indication whether the child actually understands. Because yes, in the case of the money, the child may be able to identify the denomination, right? This is $50. You buy something, and if the child can give you the change, and you question the child, and the child can tell you how much change that is, clearly you can see maybe the child might just be an outlier. But we have to, in terms of catering for students who are advanced, I am all for it, but we also have to be careful that we do not go too far with them to confuse and frustrate them. But for me, I'm all for challenging the child who is ready, not on the surface, but through deep questioning to see whether the child understands and the child is ready to move a step ahead. That is, if you can accommodate the child within the setting of the classroom among the other students that are there, so that you do not disrupt or you leave anybody else behind. Once you can balance, why not?
And on that note, we are going to bring this wonderful first session to a close. You know, we as educators, we can keep talking about math. We are enthusiasts. We love what we are doing, but we do need to bring this to a close. So we thank you so much for the question. Venita, and all those who have contributed so much in the chat, your engagement throughout, it has been absolutely amazing. So before we wrap up, just a gentle reminder, please help us to get the word about our monthly professional development sessions out. I have seen strong representation from St. Lucia, St. Vincent, St. Kitts, Dominica, Antigua. I'm not sure I have seen Montserrat. So we need to get them on board. I haven't seen enough of my colleagues from Antigua. We need to get them on board.
Grenada, yeah, a lot of Grenadians.
Oh, yes, 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 yes. You know, I had to mention Grenada for sure. Yes, yes, Grenada, you are in the house. And we have some Jamaica in the house, but we have some countries that we are not seeing enough of. So please get the word out once you get the link and the flyer for the next session, which is October. It's not the 4th Tuesday this time because we had to push it up October 21st. We are back at it, continuing to develop ourselves. And please, I want to highlight that the Act in Math, which is the Advancing Caribbean Teachers in Math project, it is more than a webinar series. We are part of a growing community of practice and an action research initiative as well. Where together, we not only learn new strategies in this session, but we also implement them in our classrooms, reflect on the process, and we grow as a regional community. So some persons already, I know from St. Vincent for sure, St. Lucia, they are part of this action research where we are saying, okay, I came to this session and I've learned about Base-10 tools. We are now going back to our classrooms to try and experiment to see how is it working? How do we need to tweak what we have learned, etc. Because we need to go beyond just hearing. We need to go towards doing and actioning. That's why the name of the project is ACT. So it has different meanings as to what ACT means. So we are acting in terms of implementing what we have learned into our classrooms. And again, we have our growing community of practice. We'll find out if you are interested, if you are not, etc. You can come on board. This is really, really a movement over the entire region that we want to say we have to improve our math learning outcomes. We cannot continue where we are at, and we can do it. Importantly, you may be wondering if you have come as a secondary school teacher, you are saying, are the sessions for me? Yes, these sessions will span a range of educational levels, both primary and secondary, so that all stakeholders can find relevance and practical takeaways. So on behalf of the Commonwealth of Learning Virtual University for Small States of the Commonwealth, the University of the West Indies, School of Education, UE, MONA, our Ministries of Education, country coordinators who are here, who have done the heavy lifting of, publicizing this. I thank you for joining us today, and this is just the beginning. So remember, put it on your calendar. We are meeting every 3rd or 4th Tuesday of the month. Put it on your calendar, make it a date that you are going to be here for each of the sessions, and we look forward to your continued participation as we work together to do what? Transform mathematics education across the Caribbean. Have a wonderful evening, rest of your day, whatever that looks like, and see you at the next session. Bye, everybody.
Dr. George, just reminder about the CXE conference for math educators.
Go ahead.
Thanks. No, just to say that thanks, that the Act in Math presentation, there will be a special forum at the Caribbean Examinations Council inaugural conference in Jamaica between the 28th and the 30th of October. And the Act in Math team from across the 3 Caribbean countries, or should I say 4, will be presenting about the project and more about mathematics teaching. So please, educators, sign up. Commonwealth of Learning is giving a grant of US 250 US to the first 40 math teachers who register. So looking forward to seeing you there. Thank you.
Dr. Moore, we have a hand. Nicole, Jeremiah, go ahead.
Yes, thank you so much for taking my hand. Thanks for responding as well about sharing of the presentation, because I came in late because I was traveling from work to get in to log on. But I also wanted to know, I've shared my email in the chat. I'm interested in becoming a part of the ACT research and community of practice. I I've shared my email in the chat, so I'm hoping that persons will respond to me. I'm interested in becoming a part of the monthly PD sessions. That's also very important. I came in about half an hour late, but it has been a very good presentation, very informative. Will certainly add to the skill set. And I would like to share some of what I've learned with my community of teachers. So it is an important thing for me to become involved. So hoping that the chat will be noted and the information shared, someone will respond. Thank you so much. Good afternoon, everyone.
This is amazing. Thank you so much. This is the vision that we have, Nicole, Jeremiah, and thank you for saying that you're going to now share with your own community what you have learned. And we are just ending on a note because our math teachers are very, very, very creative. We see Little Island Big Dreams saying that ACT could also mean apply, compute, think. So people are coming up with different ways of representing this ACT term and ACT project. So that means you're taking it and making it your own. And this is absolutely fantastic. We will be looking in the chat. If you have put down your information, you have told us how you want us to interact with you and interface with you beyond the session, we will do our very best to do so. So thank you once again for coming out in your numbers and staying, not just coming out, but remaining till the very end. Take care, everybody. Have a good rest of your evening. Bye-bye.
Bye.
Bye-bye.
Bye-bye. Thank you.
Thank you.